Good morning. My name is Mansi Shah, and today I'm really excited to talk with y'all about creativity with COGS, or how I use Cloud Optimized GeoTIFFs to make art. But first, a little bit about myself. I'm a software engineer at Planet, specifically in the developer relations team, where I get to be an advocate for developers and technical users of Planet's data and platforms. I'm also a self-proclaimed tree hugger, aka eco-nerd. I'm sure many of you all are as well, so I might be just preaching to the choir right now. And I'm also a classical musician, and I'm always looking for ways to bring together these varied interests in creative ways. So one day I had an idea. As a classical musician, specifically in the Western classical tradition, a lot of the music I play looks like this. Traditional written scores with the staff. I also play a lot of contemporary music, a lot of which uses graphic scores and prose scores as a basis for improvisation. A lot of them look like this, or like this. So I had an idea. I was wondering, can I use satellite imagery as a musical score? After all, a score offers a musician guidance about how sounds move through time, just like a satellite image is a snapshot of the world at a given point in time. So I figured if I strung together enough satellite imagery to see the world change through time, I could sort of read that as one would read a musical score. So I started looking into the details to see how this would happen. So I knew I wanted to use Planet's Fusion data product for gap-free cloudless imagery. And specifically, I knew that I wanted daily imagery between 2018 and 2021 stored, that would be stored in Google Cloud Storage buckets. Given the nature of the Fusion tile I was looking at, I knew I was going to be looking at about 300 meg per image for the area I was interested in. And I knew that I would ultimately need to download these images to my local machine for making a video out of them. So 4 years of data, 365 approximately images per year, about 300 meg per image is a lot of data, enough to drive someone a little bit insane. And this was just for one image. What if I wanted to look at multiple areas, say within that image, or maybe just multiple areas in general? That's a lot of data. So I started looking into other options. Then I learned about COGS. I learned that COGS would allow me to easily access my image directly from my Google Cloud Storage bucket. It would also allow me to easily access individual bands and image subsets. So I wasn't going to have to work with the whole image at once if I didn't want to. And I also learned that I could specify a particular subset of the image to be downloaded. So I didn't have to download the whole thing if I didn't need to. So I decided, why not? Let's give it a shot. For this example, I'm looking at Greenwood Cemetery in Brooklyn. So here on the left, I've identified that area using geojson.io, and I have the coordinates for it. Then I wanted to get the coordinates for that in the original images coordinate reference system, just to make sure things were lined up. And then I processed that subset on the fly and saved it locally. I just wanted to make sure the bands were in the right order and that it was in the right compression, etc. So the beauty of COGS that allowed me to do this, I got to work with the same high resolution data that I wanted to work with, but directly in the cloud. This allowed me to save processing time and space because I was only working on that small subset window. And I only really needed to download that because that's what I needed instead of downloading the whole imagery. So 4 years, 365 approximately images per year, only about 15 meg per image, which is 22 gig. That is pretty workable. And that was just for one image. So I could work with more images than that if I wanted to. So some takeaways I took from this project. COGS and other cloud-native geospatial technologies really allowed me in this project to be flexible and to exercise my creativity. I am also pretty new to the cloud-native geospatial space, and there were times when I felt stuck and didn't know what to do. There will always be folks willing to help you when you get stuck. This is a really supportive community, and we're all learning as we go. So definitely don't feel like you're alone in that. And also, if you dream it, you can do it. This is just an idea that I had one day and I wanted to see if it would happen. So I encourage all of you, if you have an idea of something you want to try, go for it. And we're all here to support you. So you might be wondering, what happened with that project that you were just talking about? So the project is called Counterpoints. It takes satellite imagery and data reimagined as a visual musical score. And I ended up going with 6 locations around New York City, not just Greenwood Cemetery. And this project actually premiered during New York City's Open Data Week in an exhibition this year. Here's an example of the scores used in the project. The leaves were from a data set about Greenwood Cemetery, about the trees in the cemetery, superimposed with the Brahms Requiem. And you can see a snapshot of what the project looked like here. With this project, I was interested in addressing questions like, how does our experience of a place change as we move through it? Or how has our understanding of place, especially during the pandemic that we're in, shaped our experience of our surroundings? You can view the full project if you're interested, including all the videos, audio, and scores at this website. And with that, thank you. Again, I would love to hear your thoughts on the project if you're able to view it. And I would love to hear from you in general with your questions, comments, or just to say hi. Thanks again, and hope you enjoy the rest of the conference.